Hi Year 12s. In this video, we're going to look at some stuff around negative indices. And so we're going to introduce it by just first reviewing this kind of example here. And so you should have seen a lot of questions like this previously, a to the power of 5 over a to the power of 2. And there's a couple of ways we can look at a question like this. One is where we think of it, a to the power of 5 means we've got a times a times a times a times a divided by a squared, a times a. And what happens is that a over a cancels out. So each a on the top can cancel with an a on the bottom, leaving us with a to the power of 3. And another way, shortcut way that you would have seen for thinking about this is when we're dividing with powers, we can do a subtraction problem. Since there's a power of 5 on the top, take away a power of 2 on the bottom, that means we'll have a to the power of 3 left. And we can see that both these answers are the same. So these are two methods that work. Now, if we think about the second one here, a to the power of 2, a times a over a to the power of 5, a times a times a times a times a. When things cancel down, one a with each a on the bottom gets cancelled, we'd still have like invisible kind of 1 up there. So we'd be left with 1 over a to the power of 3. Now, if we were to think about it in terms of our shortcut method, we'd be doing a to the power of 2 take away 5 because we've got 2 on the top, 2 take away the 5 on the bottom there. And so that would leave us with a to the power of negative 3. And so you can see that this time our answers look different, but both of these are the same thing. They mean the same thing, but they're written differently. And so that brings us to kind of a general form we have here. If we have a letter with a negative power, like here, that's the same as writing that letter on the bottom of the fraction with the power changed to a positive. And so if we look at these examples here, we've got m to the power of negative 2. So using this form, we can rewrite this as 1 over, and if we're putting it on the bottom of the fraction, our power is going to change from negative to positive. All right, so next one here. So this one's different because we've got the 2 in front, 2g to the power of negative 4. And a lot of people get muddled in this one and they start writing 1 over 2g to the power of 4. But this 2 is not being acted on by this power of negative 4. So what that means is the 2 stays on top and it's just the g to the power of negative 4 that goes down. And so we have g to the power of positive 4 on the bottom. And so looking at this one here, we need to do a similar line of thinking. The negative power is applying to the 5m, but the 3 and the n to the power of 5 are not being acted on by a negative power. So the 3 at the front is going to stay on top, and also the n to the power of 5 will stay on top. And the 5m that has been acted on by the power of 2 is going to go to the bottom. And I could probably simplify this down if I wanted a little bit because I've got that 5m squared, 5 times 5. So I'd have 25m squared. So that would be a way of simplifying that one. All right, so now evaluating is about finding the answer, writing in a simpler way. And so we don't have any letters this time. And you could plug this on your calculator and you'd get an answer. But we want to try and do it kind of manually and showing our thinking here. And so 2 to the power of negative 5. So thinking of it kind of in the same way. If it's got a negative power, it's going to go on the bottom of my fraction. And the power is going to be changed to a positive. And so then that means 2 to the power of 5. 2 to the power of 5 is 32. And so 1 over 32 is the answer. Last one here, we're going to have the power changed to positive 3 and the negative 4 is on the bottom. Negative 4 times negative 4 times negative 4 will be negative 64.